Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem linked list that is sorted alternatingly. So in this particular problem, we'll be given a linked list which will be sorted in the alternating manner. And what we have to do is we have to return the final sorted linked list, which should be in non-decreasing or you can say in ascending order. So let us quickly look at the sample test case. So you can see here in the first linked list, we have been given 1, then 9, and then 2, and then after this we have been given 8, then we have been given 3 and 7. So this is the linked list that we have been given. Now in the final answer, the expected output is that we should merge the final linked list, or we should do the operations on the given linked list in such a way that we get the sorted linked list. So we should get 1, then 2, and then 3, and then after that we should get 7, then 8, and then 9. So how can we solve this particular problem? Previously, this kind of problem has been asked in Amazon and other companies as well. So for solving this problem, the very basic approach could have been that I could have stored the elements. Let's say I could have stored the alternating elements, and in terms of alternating elements, I would have stored 1, then 2, and then 3. So firstly, I would have stored in an array, I would have stored 1, 2, 3, and then after that, I would have stored the even indexed elements. So let's odd index elements, that is 9, 8, and 7 also. If I would have stored 9, 8, and 7 as well, then after that I would have reversed this second array. So then I would have got 7, 8, and 9. Then after this, finally I would have merged the first array with the second array, and I would have made the nodes. So finally the nodes would have been the node 1, then next node would be 2, then the next node would be 3, then the next node would be 7, then the next node would be 8, then the next node would be 9. But this will take a lot of time. Okay, and at the same time this will take a lot of space as well, because if I am using a separate array for storing the ascending order elements and the descending order elements, and then I'm merging them also and making new nodes, so this will take order of n plus order of n space, which is something that we don't want. We want to only apply order of n time, and we want to use order of 1 space, that is we want to do the task in constant space. So how can we do it in a better fashion? So the approach that we are going to apply, or the thought process, is going to be that we will basically start iterating in this particular given linked list, and we will split this linked list. Okay, so what we are going to do is we are only going to change the connectivity. We are not going to declare any new nodes, we are not going to declare any new array. So what you can see here is that initially when we are going to start off, so we'll start with 1. Okay, now suppose that if I will keep a list in which I will store 1, then after that I will store 2, and then I'll store 3. So basically 1's next would be made as 2, and 2's next would be made as 3, and then 3's next I would make as null. Okay, and another thing that I will do is that I will have another list that will be starting from the second element, that is 9. 9's next would be 8. This is something that I'll be doing while I'm iterating through the linked list. So 9's next I will update as 8, and 8's next I will update as 7. So then I will have the second linked list as 9, 8, as 7. So what I will do is I'll first of all write a split function which will allow me to segregate the even index elements and the odd index elements. By even index elements, I mean 1, 2, and 3 are even index elements because they are occurring at the 0, 1, 0, 2, and 4 indexes respectively according to zero based indexing. Then 9, 8, 7 are occurring at the odd indexes considering zero based indexing. So I have segregated. Once I have segregated, so I need to reverse the list. Okay, because you can see the elements are in decreasing order. So when I will reverse, then the list would look like 7, 8, and 9. Then after this, finally, what do we need to do? We just need to merge the two sorted linked lists. So you can see that what I need to apply is I want to merge the list 1, 2, 3 and 7, 8, 9. So that is something that we can do. Finally, at the end, we can just apply the merge operation. So what will happen is, in order to split the linked list into one increasing order linked list and another decreasing order linked list, we will take order of n time. So this is for the split. Then after this, what we will do is we will take another order of n time for reversing the linked list, which is in descending order. And then after that, we will take another order of n time for merging the final linked list. So overall take order of n plus order of n plus order of n time, which is nothing but overall order of n. And the space complexity for us will be order of 1, because I will not be making any new nodes, I will not be using any extra array, I'll be doing the task overall in the same array only, right? So let's try and see how we can implement the functionality. I hope that you are clear with the intuition part. If you are clear so far, so you can comment down +1 or understood in the chat if you have understood so far. So what we have to do here is basically, in this particular case, we have to split, right? So we need to write a split function which will give us the head of the first linked list, that is 1, 2, and 3, and then after that it will also give us the head of the second part, that is 9, and then 8, and then 7. And once we have got the splitted heads, then we need to reverse the second linked list that we have got, that is in decreasing order. We need to reverse it, and once we have reversed this, then we just need to merge. So let us try and implement it in terms of code, and we'll try to understand it line by line as well. So what we need to do here is, firstly, we will be given the head of the original linked list, so we need to make a function that is split here. So in this particular case, what I can do is, I can say that we will return from the split function, we are going to return two heads, okay, because there are two different linked lists that I'm going to get. One linked list is in increasing order, that is the even indexed linked list, and another linked list that is on odd indexes, it is decreasing in order. So I need to return the head of two different linked lists. So that is why from the split function I will receive two different heads. Okay, so what I will do here is, I'll say that new heads, I will get the new heads in this particular variable. Okay, and once I have got the new head, like from this function, so I'll write a split function here. Okay, and in this particular split function I'm going to initially pass the head. Suppose that once I have got the new heads, then what are the tasks that I need to do? So I'll say that there is a even based linked list, and there is a odd based linked list, right? So let's say I will name it as first linked list, that is from the 0th index, and second linked list. So first linked list will be what? It will be nothing but new heads of 0. Okay, because the first head will be representing the head of the increasing linked list. So I will write new heads of 0, and then after this what I will do is, I'll write node, and then second is equal to new heads 1. So once I have got the first linked list that is in increasing order, and the second linked list that is in decreasing order, then what I need to do, I need to say that I need to update the second linked list with the new head, that is with the head of the reverse linked list. So basically I can call a reverse list function, and in this particular function what I can do is, I can pass the second linked list so that it can get reversed. Once it gets reversed, then it will also look in the sorted ascending order format. Now after this what we need to do is, we just need to merge the two lists, that is because both the lists are in sorted order. So finally we need to apply the concept of merging the two sorted linked lists by initially passing their head. So I will pass the head of the first linked list and the second linked list, and notice that we are only changing the connectivity, we are not going to make any new nodes here. Okay, so what we will do here is, first of all, in this particular function we can declare a static function which will return us the head of two different linked lists. One is the ascending order even index linked list, and another is the descending order odd index linked list. So we'll write node, and then we will write split list. Okay, let's say we'll write split only, and then I'm going to pass the head of the original linked list. So I'll pass node head here, and then what we are going to do here is, we'll simply say that node first is equal to nothing but, let's say I need to make the head. So in this particular case, since I might be using it, so I will update it as node first head is equal to new node. So I'm going to take a dummy node basically, and this would like initially I will mark it as -1. Why I'm taking a dummy node? So when I'm going to build the linked list, suppose, so like in this case what will happen is, like firstly I'll have -1, then I'll have 1, then I'll have 2, and then I'll have 3. And when I'm going to build the second linked list as well, then I'm going to have -1, then I'll have 9, 8 and 7 here. And then after this what I will do is, like once I have this, so this is where my first head will be standing, and this is where my second head would be standing. So then at the end of the day you can see that I need to do what, like wherever the first linked list tail is, that I need to check it with second head dot next. Okay, so I'm having a dummy node because initially we wanted to add the nodes, otherwise we have to write extra check conditions. So what we are going to do here is, we are going to basically declare another node, let's say node second head, and this will be nothing but, let's say, new head. So new node, so basically this also I'll be initializing it as -1. Once I have decided for my first head and the second head, then after this what I need to do is, I need to have the current f. Current f will indicate the current node of the first linked list that I'm changing the connections, and current s will indicate for the second linked list. So what I will do is, current f I will initially mark it as at the first head. Okay, then what I will do is, I'll also say that node current s is equal to nothing but second head. Okay, once I have stored the heads, then what we need to do is, then we also need to have the current pointer initially at starting from the head, and then after this we will check. So what we will check is, we'll check if the current node that we are at If it is not equal to null, then we need to keep on iterating inside the linked list. So what we will do is, like when we are at a particular current node, so in this particular case we will say that currents, like for the first linked list, its next would be updated to what? Its next would be updated to current, and then current f should be equal to current f dot next. I'll explain this with the dry run also. Then after this, what we need to do is we need to move our current to the next node because the current node has been processed. So basically, first of all, we'll process the even index node and then the odd index node, like this. So then after this, what we will check is we'll check that if the current is not null, because after updating it will move to the second node, that is the odd index node. So if it is not equal to null, if it exists, so if it exists, then in that case I need to add it in the current s. So I will basically say that in the current s, in its next will update with the current node, and then after this what we will do is we'll say that current s is equal to current s dot next, and then after that we will simply say that current should also move by one node so that it can move to the next even index node. Okay, so this is how it can keep on moving. And after this particular part, once this particular loop, let's say, is over, then as I said, the ends might be pointing to something. So that is why what we'll do is we'll mark its like current f next as null, and then we'll also mark the current s next as null also, so that if they were pointing to anything extra, so that is just removed. Okay, now once we have got this, then what we need to do is we need to store this in a result. So we can say that node result is equal to what? Is equal to, basically we are making a pair, so we can do what? We can say it as nothing but first dot next. Why first dot next? Because the initial node was dummy node -1. Okay, then we can mark also, then we can also return the second dot next. Second dot next is the decreasing order linked list, and we are returning its head also. Then once we have got this, then we'll simply do what? Then we'll simply return this particular result. Okay, so let me do a dry run so that you can understand it better. So suppose that if I have a linked list which is like 1, then I have got 9. Okay, then what I have is, then let's say I have 2, and then I have got 8, and then what we have is let's say we have got 3, and then we have got 7, and then we have got null. Suppose this was the linked list that I had. Let me just check: 192 and then 837. Yes, so this is the linked list that we had. Now in this particular linked list, what I'm going to do is my current is going to start from here. Okay, and you can understand that my first head will be standing at -1 at a node -1, and the second head also will be standing at a node, let's say, -1. Now after this, what I will do is, if I'm starting with my current, so in this case you can see that current f will also stand here. Now since I'm going to start, so current node is this particular node, so I'll say that current f dot next will get updated to the current node. So it will get updated, this node will start pointing to this particular node, that is 1. Okay, now in this particular case what will happen is, after this node points to 1, okay, so we have not made a new node, we are just changing the connectivity. Then after that we'll move our current to the next node, so current will move here, and we need to move our current f to this particular position, because now this is the tail of the first linked list. So that is why we are always moving the current first. Okay, so that you can see here, what we were doing is we were basically moving our current f, we were pointing our current f next to the current node. Okay, that is the even index node. Then we were moving our current next, and then we were moving our current f as well. Why? Because it should point here. Now after this, what we will do is, since now the current is not null, so this is the odd index node. So if the current is next, like if this is not null, then we'll update this to 9. So what we will do is current s dot next will update as this particular current node, that is 9, and then current s will move here. Okay, and then we'll allow our current to move to the next node. Now again we check the current is not null, so then we will say that current f dot next will be updated to this node 2, that is current. Okay, so 1 will be pointing to 2 now, and then after this what we need to do is we need to move our current to the next node, so current will move to 8, and current f will move to this particular node. So that is why we are always moving. Now in this particular case, since the current is not null, so we need to update it at the odd index, so we'll update the current xness as 8, and then after that we'll move our current to the next node, and then we'll move our current s also to this particular node. And you can see one by one we are getting the list, and at the end of the day I'm returning first head dot next, so that I can return this starting point, and I'm returning second end dot next, so that I can return this particular point. So I hope that you are clear with the thought process, like how I am going to split, because that is the main thing. And once I have split it, so for the second linked list I have to reverse the second linked list. So I'm assuming that you already know what is the logic for reversing a linked list, because explaining that here would take a lot of time. So what we need to do here is we also need to complete the function that is reverse list, because in that particular function I'm going to reverse the second linked list, which is odd index linked list, which is in decreasing order, and I need to make it in increasing order, that is ascending order. So what I will do here is I will simply say that I can declare a static function which will return me the node of the reversed linked list. So I need to write static node, and then I need to write reverse list. Okay, let me check if the function name is correct. Yes, so the function name is reverse list. Then what I will do here is I'll pass the node head. Okay, and then here we will simply have node current is equal to head. Okay, then what we will have is then we also need a previous variable, so previous we can initially mark as null, and then we also need the next node, so we can mark any as null initially, right? So this is what we can do here. Now once we are done with this part, so we'll always keep on moving until the current is not equal to null. So what we will do is we'll say that while the current node is not equal to null, till that point of time you can iterate. And then in this particular case, first thing is that we'll update, like we'll store the next. Before updating the currents next to previous, we need to store the currents next. Okay, so we need to store currents next, and then after this what we will do is we'll say that current next will be now pointing to the previous, and then after this part is done, then in the next iteration the current node will behave as the previous node, and the current node will be nothing but current is equal to next that I had already stored. Now this will help me to reverse the linked list, and whenever we reverse the linked list, then previous always points to the head. So just in case if you want, so I'll explain the reverse, how the reverse logic works. So what you will do is, suppose that if you had a linked list, suppose that you had 9, then you had got 8, then you had got 7, and then after this you had got null here. So initially what we will do is we will have a previous variable. So let's say initially we will have a previous variable initially which will be pointing to null, and then our current would be here. Now you know that like currents next I always want to point as previous node, so initially the previous is null. Okay, but before that if 9 starts pointing to the previous node, because every node wants to point to its previous node, so whatever current node I am at, it always wants to points to its previous node. That is one thing. So before that what we need to do is we need to store the next node, because if this 9 points to the previous node, then this connectivity to the rest of the linked list will be lost. So before that we need to store the next node. Okay, so we'll store the next node, and then what we will do is we'll say that currents next will be pointing to previous, so 9 would be pointing to the previous. Okay, 9's next would be pointing to previous, and then after that next, for the next iteration my this connectivity is lost, and for the next iteration my previous will be nothing but at the current node, and then the current will be at the next node, that is any. So current will move here. Now again for the current node, I like for 8 I want to mark its next as what, 9, because I want to shift the pointer from 8 to 9. Okay, the direction. So in that case what we will do is we'll again store the next node, and then current's next connection will now be pointing to what, will be pointing to the previous. And in this particular case again you can see that my previous will be moving to the current node, and the current node will be moving to the next node. Again the current is not null, so what I will do is I'll say that we'll store the next node, and then currents next will be pointing to the previous node, and then previous will be moving to the current, and the current will move to the next node. And the moment the current points to null, then we stop, and you can see that actually the previous pointer is pointing at the head of the new linked list, because now I have got 7, 8 and 9 linked list, and 9 is pointing to null here. So I hope that you have understood how we are applying the reverse logic. Now ultimately we will just write the code for merging the two lists. Okay, so what we need to do here is we need to write the code for the merge part. So what we will do is like let me check. So yeah, we have written the function as merge lists, and then we will pass the head 1 and the head 2, let's say. So I'll pass head 1 and the head 2. Basically it will indicate the head of the first and the second linked list. Then after this what we check is that suppose that if the head 1 was null, so if the first linked list was empty and the second linked list still had some node, then I will return the head of the second linked list directly, because I don't need to explicitly check. Otherwise suppose that what happened was if the head 2 was, let's say, null. Okay, so let me just write this properly. Suppose that if the head 2 was null, in that case we just need to return the head 1 here. Okay, otherwise if the data existed in both, then I will say that if the head 1 data, let's say if it is lesser than the head 2 data, right? So in this particular case what should we do? Let's say head 2 dot data. So if the data of the head 1 node is less than the head 2, then we can say that currently our temporary node will be pointing to this particular head one, because this particular node will be the lesser node, so I need to focus on it. And then for this particular node, I'll say that its next will be pointing where. So this, for this temporary node, now like since I've declared it, so let me just write it here, node temp. Now for this particular node, its next would be nothing but I'll call the merge function again. And since I've used the head one, so now the competition will be between the head no head one dot next and the head two here. Otherwise, suppose what happens is that the head two data is lesser, then currently I would like to explore the head two node. And then after that, for the temp, its next would be updated to what? Its next would be updated to nothing but the merge lists function. And here I will pass the head one directly, and then I will pass head two dot next, because since I've used the head two, so I need to move to the next node. Okay, and this will eventually keep on happening unless one of the linked lists is exhausted. And then after this, what we will return is, we'll just return the temp here. So let me write this part. So we'll just return the temp here. Okay, now in this particular case we had this. Okay, so we have to write merge list here as well. Let us try and compile this code and see what are the compilation mistakes, if I have made any. Okay, a colon was expected, so I have not made a colon here. Okay, now I think it is fine. Let's try and compile it again to check if it is working fine or not. It is trying to evaluate my code now. So yes, there are several issues in this code, that is first and the second. Okay, node heads one, then result also cannot find symbol result. Okay, so there are a couple of issues. Let me just fix them. So what we have done here is, now once we had declared the, let's say, the new heads, so then inside the new heads, what I will have is, once, suppose that once we had got the new head, so inside the new head 0, like I will get this thing, and like first and the second nodes. So I have passed the head, and then after that the second is equal to this, and then I have written the result here. So let me just check if there is any issue in the split function. So in the split function, what I was basically returning was the head dot first dot next and the head dot next, and then I'm returning the result. Okay, so cannot find symbol. Okay, so node second is equal to new heads. Okay, so there is a spelling mistake in the heads part, I guess. Let's fix this. Okay, yes, I have made one more mistake. I should write first head dot next, and then I should write second head dot next, because actually first and second did not exist. I was writing first head and second head. Okay, now there is a mistake in temp variable name, so let us fix that also. And compile it now. Okay, so now you can see that I've fixed the issue. Basically there was a small spelling mistake, so I've just changed the spellings. Let's try and submit it to check if it is getting accepted. So you can clearly see that our problem was able to get accepted. Basically this was a long logic based problem where you had to implement each and everything, firstly splitting the linked list, and then after splitting you had to also reverse the second linked list, that was in decreasing order, and then you had to merge the two sorted linked lists. So this question uses a lot of approaches. I hope that you have understood this clearly, and make sure to comment down understood. Thank you guys for watching this video.